epigenesis. It deals with the creation of light, which chased away the darkness. And we are not talking yet, not about the sun and not about the moon and the stars. But we should expect that two important things would come out of it. The first is photoreceptors to sense the light, and the victory of light, which is considered positive and good, on dark, which is considered negative and bad. And if we look at our evolution, it took place under light-dark cycles. Although humans, from the beginning of the human evolution, were looking for ways how to increase the photophase as we are diurnal organisms. So what happened in the last 136 years to our planet? The invention of illumination in which electrical energy is converted into light, or is modified into light. And this is a new era for our planet, resulting from what we call today artificial light at night, which we know today that it's a source of pollution. We call it light pollution, and we can even call it light toxicity, as we know today light at night is toxic. So these are some stages of the evolution of light, starting from fire, and this is the ultimate illumination, which we are using today in many places, and it's invading our lives in a very aggressive way. And this is the LED, the light-emitting diode, and we'll get to it very soon. So, as I said, we are diurnal, and we were looking for ways how to increase the light hours in the 24-hour cycle. And the point is that if we look at natural illumination, it's not only the intensity that changes during the 24-hour cycle, but it's also the spectrum of light that comes to our planet. So in natural lighting, we have, as I said, changes in spectrum where during the day hours, the short wavelength illumination is the dominant illumination. The longer wavelengths, which go deeper into our eye and into our body, appear in the later afternoon and go into the evening, although they exist, but they're not dominant in the morning. And if we look at this slide, so we can see here that when we wake up in the morning, the intensity of light is low. The dominant wavelength is a short wavelength illumination, which increases together with the dominance, increases together with the intensity. And here in the afternoon, it changes into red, to the long wavelength illumination, and it goes into the night, but with a much lower intensity. But still, the light of the moon, which comes to our planet, is not a short wavelength, but rather a long wavelength. Look here what happens at the hour of, if this is a 12-hour light, 12-hour dark, about 1 hour and a half after sunrise, the melatonin secretion stops, and the melatonin is, as you know, produced and secreted at night from the pineal gland, not only, but we know it's secreted. The greatest part of melatonin in our body comes from the pineal gland during the night. So this is the spectrum. Again, the short wavelength at daytime, long wavelength in late afternoon and in the evening. Now, If we look at our eyes, we can see that in the retina, we have different photopigments which appear in different photoreceptors. What was known for many years were the rods and the cones, and in regards to the rods and the cones, we know that the rods contain the rhodopsin, and the cones contain the opsin. In the last 15 years, we know, or we are aware, of a new photopigment named melanopsin, and this is a pigment that we find in what we call today the non-image forming photoreceptors in the retina. So this is the mole rat, the blind mole rat, which is considered blind, and some 35 years ago, we could show that the blind mole rat knows if it's a long day or short day, although it is blind. And this opened a new era for studying the retina and understanding that there is another group of photoreceptors which were once considered as ganglia only. Today we know they contain the melanopsin, and they are considered as non-image forming photoreceptors, and they are very important for our circadian system because they entrain the circadian system with light coming from the environment. Melanopsin is very sensitive to short wavelength illumination, and when this is in the environment, and it's picked up by the ganglions or by the melanopsin, the signal is transferred to the pineal gland. We can see the way it goes, and the pineal gland stops producing melatonin. This happens during daytime. The information goes from the retina in a special pathway, the retinohypothalamic tract. It's not the optic nerve, and it goes to the biological clock. From there, it travels in a nervous network to the pineal gland. And what is interesting is that the biological clock gets information, which is neural information, but it also has receptors for melatonin, so it also gets a neurohormone, the neurohormone melatonin, which affects the biological clock. So the problem is, today we can say very clearly, is the blue light. The blue light suppresses melatonin production. And this is known in psychology and in chronobiology as the light in which you treat people with seasonal affective disorder. You just put them in front of fluorescent, or today LED illumination, which suppresses melatonin. So what we are doing today is, with the illumination that we created of short wavelength for energetical purposes, we are confusing our pineal gland. At daytime, blue visible light is important. It's important for suppressing melatonin production. At night, we need darkness or red light, but not blue light in the range of 460 and 500 nanometers. So if we look at the relations between daily rhythms and brain chemicals, during sleep, there is an increase in melatonin, which is synthesized from serotonin in the absence of blue light. If we have blue light in our room coming from the TV or a computer screen or from our smartphones, this can stimulate the melanopsin and it will suppress melatonin production. At daytime, when we are awake, dopamine, serotonin, both are synthesized in the presence of blue light from tyrosine and tryptophan, respectively. And if we look at this slide, so we can see that tryptophan at daytime is from tryptophan, serotonin is formed. This is during daytime. The serotonin is accumulated in the pinealocytes, and when it is dark and there is no blue light in the environment, serotonin is transformed into melatonin in 2 stages. If we interfere here with blue light, we stop the synthesis of melatonin. So the problem is, again, our electrical energetically efficient illumination. I cannot understand if really there is anything behind it in regards to efficiency. If you want to be, if you want to save on electricity, just put off the light when you leave the room, or if you have a corridor in a hotel where people are not moving in the evening, so you can put the lights off, and you have sensors that can put them on when someone is passing through the corridor. There are all kinds of ways to save on energy. But we preferred the worst way to save on energy in regards to illumination, where we are using a type of illumination which does not exist during the scotophase, during the dark period of the 24 hours. So, but we are humans, and we adore new technologies. And if we look at all the new devices of technology, they all contain LED. If it is in the screen, if it is in the indicators, we adore the blue light. Many, I don't want to say names, okay, but like to decorate if it is the hotel or the bank or whatever it is, with blue light. And this is at night, when such illumination is pollution. And no one does nothing about it, because, again, we adore light. We are humans, and we adore light. So what is the problem? Why? So we won't produce melatonin. What is so bad about not producing melatonin? This is the Bay of Haifa, and people are concerned about air pollution. But they don't care about the light pollution at night, and where all the illumination is changing slowly from orange type, from the high-pressure natrium, into energy-saving illumination, and the increase in cancer and other sicknesses is all related to air pollution. So I would like to, just before I'm going to show you our experiments, I would just like to say a few words about epigenetical modifications. We think of mutations, but mutations occur very seldom. They are very rare. It doesn't occur in the amount we think it can occur. There is, and we are aware today, that in response to changes in the environment, we can have changes not in the sequence of the nucleic acids which form the DNA, but in the histones or in the envelopes that coat the DNA. These changes are known as epigenetical changes, and in our laboratory we are studying or in our center, research center, we are studying the nexus between these factors in order to understand the relation between environmental changes and breast cancer, modulated by melatonin suppression through global DNA methylation. We use the biopsy mice, females. We inoculate them subcutaneously with 41 mice breast cancer cells, and we can measure the size of the tumor with time. Before sacrificing the mice, we keep them for 28 days. We are not allowed to keep them under some conditions of illumination for more days because the tumor is very aggressive. It grows very quickly. So after 28 days, we sacrifice them. And before sacrificing them, we collect urine every 4 hours, and we measure the levels of the melatonin metabolite in the urine, which is 6-sulfatoxy-melatonin. And when we sacrifice the animals, we remove organs and the tumor from the animals, and now we can immediately study epigenetical modifications by using the global DNA methylation. These are commercial kits. It's, you don't need very sophisticated equipment for it, but it's a very important test that we carry out in regards to our research. So this is here just to tell us what epigenetics are, or what it is, what epigenetic is, and this is what we are doing. We are looking at these modifications which actually can change the expression of genes. Genes that were not expressed when the genome was methylated to a certain level may be expressed if there is hypomethylation. Now, what is very interesting about epigenetics is that these processes are reversible. If we remove the environmental change that we caused, if it is light at night, if we remove light at night, then the process is reversible. And as you would know, it takes about 10 to 15 years for breast cancer to develop. And breast cancer, a part of the cases is an outcome of epigenetical modifications. And what we see here is that this is the DNA, and these are what coats the DNA, and this what modifies in epigenetics. Okay? And melatonin has to do with it. We'll soon see how. So there is the enzyme methyltransferase. It plays a very important role in the process of methylation or demethylation. And melatonin may activate this enzyme. And I want to show you now some of the results we have from our laboratory. This is from an early study where we could show that if we take, this is the control mice that were not exposed to light at night. These are mice that were exposed to 30 minutes of fluorescent illumination. And as you can see, they were exposed to light at night, and you can see that they, relatively to the control, they are losing, or the levels of methylation are lower. But when we have the same group interfered with light, but we add to the water, to the drinking water at night, from when lights are off till the morning, we add melatonin, so you can see the result. The levels are coming close to the levels of the control mice, which are not interfered with light. Here, this is from a recent paper, and we can see that there is a great difference in the size of the tumor, or in the volume of the tumor, between two types of illumination. This is the incandescent bulb, what we were using till about 20 years ago. Now in Europe and in Israel, we are restricted to 60 watts bulbs. You cannot buy in a higher intensity. And this is the incandescent, and here we have the blue LED, and these two are without melatonin, and these two here are with melatonin. So this is the size of the tumor at the end of the experiment, 28 days, of the LED exposed females. You see, it's much higher than the one of the incandescent bulb. It's here. And when we treat both groups with melatonin, melatonin decreases the rate of proliferation of the cancer cells. This is the problem of lead. It's the peak that you can see here, which affects the melanopsin and suppresses the melatonin production. What they're trying to do today is to remove this peak from the LED. The problem is that you can come out with the bulb and you say there is no blue because we added phosphor or other chemicals. But chemicals change their properties with the time. So maybe today it's a good bulb, but in 2-3 years, no one tests what are the levels of the blue illumination. So here we have, this is levels of melatonin under the incandescent under the incandescent bulb, and this is under the LED. The suppression is high, and what we can see here are the levels of global DNA methylation. We have here the tumor, and we have here the blue and the yellow, the incandescent bulb with melatonin and without melatonin. And you can see that there is a difference in the levels of methylation. There are differences in the liver, and there are differences in the other tissues that we were looking at. Now, this is a very important figure, and let's go through it together. What we have here is, this is the global DNA methylation. This is the levels of melatonin production measured through the metabolite in the urine, and this is the tumor volume. Now, if we look what happens with the tumor volume, when the levels of melatonin are low, the volume is high. But also, the global DNA, the DNA methylation is low. When melatonin levels are high, okay, the tumor volume is reduced, and methylation is high. So this is the connection between the three, and I do believe that such figures in the future will be very important. This is taken from mice. If you would have such a figure from humans, it could help us because we may be able to detect breast cancer before it is even a cancer, before or on the way it's going to develop into a cancer because of modifications in the genome or the epigenome and reduction of melatonin production. This is how Israel looks at night. This is light pollution over Israel and some other countries of the Middle East. This is the delta of the Nile. This is the area of Tel Aviv. We are very worried about air pollution, but our Ministry of Health and our Ministry of Environmental Affairs is not worried about light pollution. This is not a problem for them. This is how our world looks, and we just sent a manuscript showing the relation between light pollution worldwide and obesity and overweight. And there is a very nice correlation. In countries that are over-illuminated, there is a high percent of obese and overweight people. So the light-emitting diode, this is the ultimate illumination. I'm going to be in another 2 weeks in London talking to people who are producing the LED and trying to explain to them why it's a bad illumination. The natural LED, the blue-white LED, that the people who developed it received the Nobel Prize last year. I don't come from physics, so this could be a very important invention in physics. But in regards to the environment, which was the justification for the committee to give them the Nobel Prize, here I can say something, and I think that it was a mistake to give on the name of environment the prize to these people. I think that first of all, we must be aware that light of short wavelength is a source of pollution. LED, because of its high intensity, is the worst among the short wavelength illuminations, and this is a risk for our health. Now, if it is in my home, I can do whatever I want. The problem starts where or when in public spaces this illumination is used. So here we can see some of the functions that melatonin is involved. Melatonin in the literature is known as the jack of all trades, and you can see why. It's involved in the reproductive system, metabolism and thermoregulation, cardiovascular system, immune system, the nerve system, hormone-dependent cancers as breast cancer and prostate cancer. It's a very important antioxidant, and it is an important anti-aging agent. So, and when we grow older, we produce less melatonin, and therefore it is important not to interfere with the minimal amounts that we are producing. So what is the take-home message? Artificial light at night is a source of pollution, which decision makers and regulators should not ignore anymore and should act accordingly to decrease the levels and avoid the use of short wavelength illumination. Creating a biological definition for light pollution. We have no biological definition for light pollution. The definition comes from the astronomers, not from the biologists. We know nothing about thresholds, okay? And we must support integrative research on this topic in order to create smart illumination, which is energy efficient. I'm not against saving energy, but it cannot come on the account of risking human health and disrupting natural ecosystem, disrupting our biological rhythms. Our temporal organization is completely destroyed, and we need to produce what we would think of as sustainable illumination. Thank you for your attention.